Hello friends, today we are going to start the new unit number 5, sequence and series. In sequence and series, actually our topic is on infinite series, but before starting series, we will see what is meant by sequence. So this sequence is a real sequence. So definition is any set of real numbers, any set of numbers, this a1, a2 up to so on an, such that to each positive value of n there corresponds a number an is called sequence, and it is denoted by an. So how we write sequence an? Sequence an is equal to, if you take 1 by n, then for n equal to 1 means how we write sequence an here. For n equal to 1, sequence an is equal to first term is a1. Okay, first term is a1, that is if you put here n is equal to 1, then first term is 1 by 1 is 1, then n equal to 2 we get a2. A2 is here 1 by 2, then n equal to 3, a3 is 1 by 3, n equal to 4, a4 is 1 by 4. So this is one sequence. If you take another example of sequence, that is suppose if you take sequence an is equal to your roll numbers. Okay, roll numbers. So roll numbers, how we write here, that is say a1 is first roll number 1, a2 is roll number 2 up to so on roll number 60. So this is one sequence. This sequence is finite sequence because we can count number of elements here. This sequence starts from 1 to 60 and sequentially, so this sequence is called as finite sequence. What is meant by infinite sequence? Infinite sequence means upper bound is not fixed. Sequence starts from 1 to infinity. Okay, so that is called as infinite sequence, and from sequence we have to form series. Okay, so next one is in sequence, monotonically increasing and monotonically decreasing. The sequence which is monotonically increasing and decreasing, that sequence is called as monotonic sequence. So what is meant by monotonically increasing sequence? Suppose sequence an given, a sequence an is said to be monotonically increasing sequence if an plus 1 is greater than equal to an plus 1 is greater than equal to n for every value of n. An is less than or equal to an plus 1 means an is, suppose if you take n equal to 1 here, so a1 is less than a2 means first term is less than second term, then second term is less than third term. Example of your roll numbers, if you take suppose roll numbers 1 2 1 2 3 and so on, this is one sequence, and this sequence is monotonically increasing because this sequence is monotonically increasing. Why we say that this sequence is monotonically? Because this is increasing sequence here. 1 is less than 2, 2 is less than 3 up to so on. So this 60 is the upper bound of this sequence, means monotonically increasing sequence means this an plus 1 is greater than equal to n for every value of n, and monotonically decreasing sequence means an plus 1 is less than or equal to an. Okay, for every n. And again one more important sequence is there, that is alternating sequence, because in our syllabus alternating series is given. So how we write alternating series? With the help of alternating sequence. So what is meant by alternating sequence? If in this sequence the terms are alternately positive and negative, such type of sequence is called as alternating sequence. Now here example, if we take first example, monotonically increasing sequence. This is the sequence of odd numbers, that is 1 3 5 7. So this is the increasing sequence, means this sequence is called as monotonically increasing sequence. Here first 1 is less than 3, 3 is less than 5 means an is less than equal to an plus 1. Second one is monotonically decreasing sequence. Here first term a 1 by 2, then 1 by 2 square, 1 by 2 cube. So 1 by 2 means that is 0.5, 1 by 2 square is 1 by 4. So 1 by 2 is greater than 1 by 4 because denominator of 1 by 2 is small, denominator of 1 by 4 is large. So this 1 by 2 is greater than 1 by 4, 1 by 4 is greater than 1 by 8. So this sequence is decreasing sequence. So the sequence is called as monotonically decreasing sequence. And third example is alternating sequence, means the sequence in which the signs are alternate. First one is positive, second one is negative, third one is positive, fourth one is negative. So this sequence is called as alternating sequence. So what is meant by monotonically increasing sequence, decreasing? This simply increasing sequence is called as monotonically increasing sequence, decreasing sequence is called as monotonically decreasing sequence, and the sequence which is both monotonically increasing and decreasing, that is called as monotonic sequence. Okay, and alternating sequence means in that sequence signs are alternate. Okay, now next important thing is how we find limit of sequence. So this is the epsilon delta definition. A sequence an is said to have limit L. Sequence an is said to have limit L as n tends to infinity if given epsilon greater than 0 there exists a positive integer m such that modulus of an minus L is less than epsilon. The epsilon is very small quantity. In simple language, what is the meaning of this total, these two sentences? That is, limit n tends to infinity an is equal to L, then we can say that L is the limit of that sequence. Okay, so next one is in sequence and series, most important thing is convergent and divergent. So what is meant by divergent? When we say that given sequence is convergent, when we say that given sequence is divergent. So convergent sequence means a sequence an is said to be convergent. Sequence an is said to be convergent if an has finite limit. This is very important. If we find limit of sequence an and if we get that limit is finite, then we can say that sequence an is convergent sequence. If we find limit of sequence an and if we get suppose that limit is infinite, then we can say that sequence an is divergent sequence. And if we find limit of sequence an and if that limit is not exist, then we can say that that sequence is oscillatory sequence. So what is meant by convergent sequence? If limit of sequence is finite, then sequence is called convergent. If limit of sequence is infinite, then sequence is called divergent, and if limit is not exist, then that sequence is called as oscillatory. So if limit is not exist means if limit exist, one theorem is there, if limit exists then it is unique. Now by example, suppose if you take first example here, sequence an is equal to 3 plus minus 1 raised to n upon n, and as n tends to infinity, if you find limit of an, that is limit n tends to infinity, 3 plus minus 1 raised to n upon n, here if you put n equal to infinity, numerator has two values but denominator is infinity, and we know that 1 upon infinity is 0, 1 upon infinity is 0, so its limit is 3. Okay, limit is 3 and 3 is finite, so therefore this sequence is convergent. So when we say that given sequence is convergent if it has finite limit. Okay, so here we get limit 3, so from this we can say that sequence an is convergent. Now we will take one problem on divergent sequence. Divergent sequence means when that sequence has infinite limit. Now if we take example here, sequence an is equal to n square, and if you find limit of n square as n tends to infinity, means here if you put n equal to infinity, then we get limit infinity. So limit is not finite, means limit is infinite, therefore given sequence is divergent. And oscillator means if you take sequence an is equal to minus 1 raised to n, if you find limit of minus 1 raised to n, it has two limits. If n is even, then we get 1, and if n is odd, then we get minus 1. Means minus 1 की पावर यदि evenly means 2, 4, 6, 8 तो वो 1 आएगा, and minus 1 की पावर ऑड ली तो minus 1 मिलेगा. Means we get here two limits. If limit exists, then it is unique. So here we get two limits. So limit is not exist, therefore this sequence an is oscillatory sequence. So convergent, divergent and oscillatory means if limit is finite, then sequence is said to be convergent. If limit is infinite, then sequence is said to be divergent, and if limit is not exist, then that sequence is called as oscillatory sequence. Next important thing is bounded sequence. Now what is mean by bounded sequence? Bounded sequence, it has two types again, bounded above sequence and bounded below sequence. Now what is mean by bounded above? A sequence an is said to be bounded above if there exists a real number m, sequence an is said to be bounded above if there exists a real number m such that an is less than equal to m for all values of n. Here m is called as upper bound. Bounded below means the sequence an is said to be bounded below if there exists a real number m such that an is greater than or equal to m for all values of m, and here this m is called lower bound. So the sequence which is both bounded above and bounded below, that sequence is called as bounded sequence. Okay, so if we will take here counter example, what is meant by bounded sequence. So if we take suppose here sequence an is equal to sequence minus 1 raised to n. Now sequence minus 1 raised to n, how we write? For n equal to 1, minus 1. For n equal to 2, 1. For n equal to 3, minus 1, 1, minus 1, up to so on. So this sequence is bounded sequence because its lower bound is minus 1, upper bound is plus 1. This sequence is bounded above and bounded below both, so this sequence is called bounded sequence. Okay, or bounded above sequence, we can take example of roll numbers again, 1 2 3 up to so on 60. Roll number starts from suppose 1 2 up to so on 60. So this 60 is the upper bound of this sequence, and bounded below sequence means if we write that roll numbers in reverse order, suppose 60, 59 up to so on 1, so this is the bounded below sequence, means monotonically decreasing, so this one is called as lower bound of this sequence. Okay, so this is the bounded sequence, bounded below, bounded above. So this is the related to sequence. Now our main topic is series. So what is mean by series? From sequence we can write series. For example, again if we take example of our roll numbers 1 2 3 up to so on 60, this is one sequence. Okay, and if we write, means first term is here a1, second term is a2, third term is a3, and if we write this sequence in series, that is 1 plus 2 plus 3 plus so on plus 60. So this is one series. How we write? This is equal to series un, and here n starts from 1 to 60, means 1 to 60 here, not infinity, 1 to 60. So this sequence is called as finite, this series is called as finite series because n starts from 1 to 60. So our topic is infinite series. So what do you mean by infinite series? An expression of the form u1 plus u2 plus so on plus un plus so on, it's called infinite series. Means u1 से start हो रहे, upper end is not fixed, that is called as infinite series, and it is denoted by series un. n varies from 1 to infinity, or simply we can denote this way also, series un. n equal to 1 to infinity नहीं लिखा तो भी चलता है. Then this is the infinite series. So how we find the sum of first n terms of this series? Sum of first n terms of this series is denoted by Sn, and is given by Sn is equal to u1 plus u2 plus so on plus un. Means Sn is equal to u1 plus u2 plus so on plus un. So how we write S1 here? S1 is first term of series u1. Okay, S2, how we write? S2 is sum of first two terms, that is u1 plus u2. In this way, what is Sn? Sn is the sum of nth terms of this series. Okay, now how we decide given series is convergent or divergent? That depends on the limit of Sn. So a series un is said to be convergent. Listen carefully. A series un is said to be convergent if Sn tends to finite limit s as n tends to infinity. Same as sequence. If sequence Sn or series Sn means sequence of partial sum. Sn is the sequence of partial sum of series un has finite limit s, then we can say that series un is convergent. If Sn has infinite limit as n tends to infinity, we get limit of Sn is infinity, then we can say that series is divergent. And as n tends to infinity, suppose Sn has neither tends to finite limit nor tends to infinite limit, then that series is called as oscillatory series. So this is related to convergent, divergent and oscillatory series. Okay, next one is some theorems are there, means the nature of series remains unchanged. The nature of series remains unchanged if, this is very important, the nature of series remains unchanged if the sign of all terms in a series are changed. Means suppose positive term series given n, if you multiply that series throughout minus sign, then also nature of series remains unchanged. Means कॉन्वर्जेंट और डाइवर्जेंट पे कोई भी इफेक्ट नहीं होता, उस सीरीज का पूरे साइन चेंज भी किए हमने तो. Second one is a finite number of terms. This finite word is very important. Finite number of terms are added or omitted from the infinite series. Means infinite series में से यदि फाइनाइट नंबर ऑफ टर्म्स ऐड किया और ओमिट किया तो भी कॉन्वर्जेंट और डाइवर्जेंट ऑफ सीरीज पे कोई इफेक्ट नहीं होता. ओके, नेक्स्ट वन इज टेस्ट फॉर कॉन्वर्जेंस ऑफ दिस सीरीज. सो दिस इज वेरी वेरी इंपॉर्टेंट. How we check given series is convergent or divergent? There are some tests, 9 to 10 tests are there. In this video we will take some simple test. In next video we will take comparison test and problems on that test. Okay, so test for convergence of this series, in which first test a geometric series test. I think you know geometric series, what you mean by geometric series. So how we check that geometric series is convergent or divergent? Using geometric series test. So geometric series test is geometric series a r raised to n with common ratio r. Here r is common ratio and a is first term of that series, is said to be convergent if r is less than 1 and divergent if r is greater than or equal to 1. This is very very important. When we say that geometric series is convergent if its common ratio is less than 1 and divergent if common ratio is either equal to 1 or greater than 1. For example, series un equal to 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus so on. So this is the geometric series. Yes or no? Here in each term 1 by 2 present, here also 1 by 2, 1 by 2, 1 by 2. So this 1 by 2 is common ratio here. So what is the value of r? R equal to 1 by 2, and 1 by 2 is less than 1 or greater than 1. 1 by 2 means 0.5, which is less than 1. So common ratio is less than 1. Therefore, the series UN is convergent using geometric series test. Means using this test we can write directly nature of this series, that is convergent. If we take second example here, second example is say 1 plus, or no 1 plus no. Second example is say 2 plus 4 plus 6 plus so on. So this is also geometric series, because here this is also geometric series. Here if you take 2 plus 4 plus 6 plus so on, 2 plus 4 plus 6 plus so on, this is also geometric series, because here common ratio is 2. In each term 2 is present, so r equal to 2 and 2 is greater than 1. So using geometric series test, this series is divergent. Okay, so this is the geometric series test. Next one is divergent test. Divergent test is also important for solving problems. A positive term series un is said to be divergent if limit n tends to infinity un is not equal to 0. A positive term series un is said to be divergent if limit n tends to infinity un is not equal to 0. Means when we say that series un is divergent if limit of un as n tends to infinity not equal to 0. But here converse is not true. Means आप लोग अभी गेस करेंगे यदि लिमिट ऑफ यू एन इज नॉट इक्वल टू जीरो है तो सीरीज डाइवर्जेंट है, देन लिमिट जीरो आया तो वो कॉन्वर्जेंट हो गया. ऐसा नहीं है. इफ लिमिट यदि जीरो आया, इफ लिमिट n टेंस टू इन्फिनिटी यू एन इक्वल टू जीरो आया, तो वी कैन से दैट सीरीज यू एन इज may be or may not be convergent. Okay, we will take some examples on this also after taking p series test. So next one is p series test. Here p series test is series 1 upon n raised to p. is said to be convergent, n to the power p here, 1 upon n raised to p is said to be convergent if p is greater than 1 and divergent if p is less than or equal to 1. This test is very important for solving problems. Series 1 upon n raised to p is said to be convergent if p is greater than 1 and divergent if p is less than or equal to 1. For example, series 1 upon n square. Compare this 1 upon n square with 1 upon n raised to p. What is the value of p? P equal to 2. So 2 is greater than 1. Therefore, series un is convergent. If we take second example here, series 1 upon n raised to half. Compare this 1 upon n raised to half with 1 upon n raised to p. So p equal to half. Half is less than 1. Therefore, series un is divergent. Okay. So using p series test, we can decide nature of series, that is convergent or divergent. Now, my question is, if limit of un is 0, then series un may be convergent or may not be convergent. So if we take example here, for example, if we take series 1 upon n square, okay, compare this series with series un, and so what is un here? Un is equal to 1 upon n square. Now if you find limit of un here, limit n tends to infinity un, इसका लिमिट क्या आएगा? इक्वल टू लिमिट n टेंस टू इन्फिनिटी 1 अपॉन n स्क्वायर, एंड 1 अपॉन n स्क्वायर, इसका लिमिट तो जीरो आया. इसका लिमिट जीरो आया, इसका मतलब क्या है? ये सीरीज क्या है? कॉन्वर्जेंट है. वाई? बिकॉज बाय पी सीरीज टेस्ट हियर p इज इक्वल टू 2a एंड 2 इज ग्रेटर देन 1 के लिए वो क्या आते हैं? कॉन्वर्जेंट. ओके, तो आप लोग बोलोगे अभी लिमिट, इफ सीरीज इज कॉन्वर्जेंट देन लिमिट इज जीरो. यस, इफ सीरीज इज कॉन्वर्जेंट देन लिमिट इज जीरो, बट कॉन्वर्स इज नॉट ट्रू. मीन्स if limit is 0, then we cannot say that series is convergent or divergent. Second example, if we take here series 1 upon n, okay, 1 upon n equate with un, so un is 1 by n, and if you find limit of 1 by n, that is also 0. Limit n tends to infinity 1 upon n equal to 0. But by p series test, what is p? P equal to 1 here, so series 1 by n is divergent. Divergent in short is denoted by dgt and convergent is denoted by cgt. So here p is equal to 1, so series 1 upon n is divergent, but उसका लिमिट क्या है? 0 है. तो यदि लिमिट 0 है तो हम उससे नहीं, ऐसा नहीं बोल सकते कि सीरीज कॉन्वर्जेंट है और डाइवर्जेंट फिक्स है. बट इफ लिमिट इज नॉट इक्वल टू 0, देन वी कैन से दैट गिवन series is divergent. If series is convergent, listen carefully, if series un is convergent, then its limit is 0. Limit n tends to infinity, un is always 0, but converse is not true. series un यदि कॉन्वर्जेंट है तो उसका लिमिट 0 आएगा, बट यदि लिमिट 0 है तो वो कॉन्वर्जेंट है, ऐसा नहीं बोल सकते हम. एग्जाम्पल है 1 अपॉन n का. Okay, so in next video we will take comparison test. So next video is very important. Okay, thank you.